Dear students, now we are in the second section of this video lecture. Earlier, I have already discussed the solution of question 1 that is asked in the internal assessment 2 in January 2022. Now we see the second question. So it was asked for 10 marks. It is given in the question a cube of side 5 units is made of laminated sheet so that with the origin at one corner the density of the material is e to the power x. So it is clearly mentioned here the density rho is what it is. Density of the material is e to the power x. We have to find the position of center of mass of the cube so that we can fit here the 1 point corner is at the origin and we define here x, y, z coordinate. So in the solution to get the center of mass, first we calculate the mass of that structure. So mass can be given as integration of integration rho dp or rho dx dy dz, whatever you have remembered. So rho is given, rho density is given e to the power x, so that we have implemented. So it can be separable in the integration form. So and the limit is what? Each side have the unit 5. So it is 0 to 5, 0 to 5, 0 to 5 for all that can be taken. So after integration, it will be what? 25 e to the power 5 minus 1. So integration of this is 5, this is 5. So 25 that we have kept here, and integration of this will be e to the power 5 minus 1. So that you must remember it is a mass of the body that we have calculated. Now to calculate the center of mass, we require the first moment of the total mass m with respect to all three planes x, y, yz and zx plane. So first we calculate about the yz plane. So according to formula, the first moment about the with respect to yz plane is what? Triple integration x rho dx dy dz. So again we put here x e to the power x dv. So again it can be separable here. So integration of this will be 5, integration of this will be 5, and integration of this we will calculate. So by integration by part that you can apply here. So it can be applied, and what we get as a result, it is what? 25 4 e to the power 5 minus 1 that we get as a what? Moment about the plane yz. These things again we must remember, so that I have written here. Now moment about the yz plane. So it will be triple integration about xz plane. So it is y rho dx dy dz that we know. So it will be written as y to the power x, and again by separation that we get. So it will be simple y. It is y square by 2. So it is 25 by 2 that you will get. So 25 by 2 into 5, it is 125 by 2. And this will be e to the power 5 minus 1 that we get as a here. So again that we must remember. And the last one will be what? In the place of y we will keep here z. So the result will be same that we get for the moment about the xy plane, this one. So after calculating all these three values and mass also we have written here, now we go for the center of mass. So center of mass that is defined for x coordinate x bar, it is what? Moment upon mass. So that we have calculated. Similarly for y dimension it is 5 by 2, and for z dimension it is again 5 by 2. That all we have calculated. You can verify from here also. So the center of mass, the required center of mass can be given as in this way. So this is your required answer. Now come to the next part, that is the last one, question number 3. So it will have again the two component, each carry the 5 marks. First one is calculate the area of the region bounded by the curve. So first what we check here, it has the point of intersection 0, 0 and 2, 1 that we know. So first we draw the graph for this one. So what we see, it will have the 2, that is y is equals to x square by 4 and y is equals to 3x upon x square plus 2 that we get here. So x and y axis that we have plotted, this is x and y axis. So first we plot here the curve y is equals to x square plus 4 or 4y is equals to x square, that we can say. Next curve that we have y is equals to 3x upon x square plus 2. So clearly it follows the 0, 0. So no issue with the origin, and it will have the curve approximately this kind of curve that we will get here. Okay, so the region that we get here, this one, the point of intersection, it is 2, 1 and 0, 0 that we have, and the area of the area or region of integration that we get in such a way. So this is the region R that we can write here. This is the region of integration. Over this we have to integrate. So integration is quite simple. So it is what? The first we have integrated with respect to y. So it is 3x upon x square plus 2 minus x square by 4 that we have kept. Now we integrate with respect to x. So it is 3 by 2 log x square plus 2. So x square plus 2 that you can, for this part, if you put x square plus 2 is equals to t. So what we get? 2x dx is equals to dt. So that's why what we have taken here, 3 by 2 and multiplied by 2. So it will be 2x upon x square plus 2. So once we integrate it, so it will be what? Log x square plus 2. And for this x square by 4, it will be x cube by 12. Now put the limit here. If you put here x is equals to 2, so it will be 3 by 2 log what we get? 4 plus 2, 6. So it will be log 6, and once you put 0, so it will be minus log 2. So it will be log of 6 by 2, that is log of 3, and multiplied by 3 by 2 that we get. Now for this term, if we put 2x is equals to 2, so it is what? 8 by 12. So 4 2 is 8, 4 3 is 12, that is 2 by 3 that we get. So this is your required answer of the first part of the question number 3. Okay, so next question we have, find the volume of solid bounded by the cylinder x square plus y square is equals to 4 and the plane y plus z is equals to 4, y is equals to 0. So usually these kind of questions we teach in the classroom also. So this can be used by double integration and used by triple integration both. So we have the x, y and z coordinate, it is given here. So first the cylinder x square plus y square 4 that we have drawn here. Now next is y plus z is equals to 4, so that we have kept here y plus z is equals to 4, this figure. So z is equals to 0 and that will be, that plate will be here. So this will be, looks like the plate will be across that cylinder in such a way. So this kind of figure that we will get here. So we have to integrate, and this area, this circle will be what? In the xy plane, x square plus y square is equals to 4 that we have. So all in above, so what we get here, for this circle, for this circle, what we have the limit for this one. So that x is equals to minus square root of 4 minus y square to square root of 4 minus y square. So what we can write here, x square is equals to 4 minus y square. So x is equals to plus minus square root of 4 minus y square that we have. So that we have taken the limit in such a way. And for y, it is what? Minus 2 to 2, it will move. If we take for one quadrant, so that also can be done. So limit is, you are independent to put the limit accordingly. And z dx dy. So z is the along z direction we are integrating this one. So in the third dimension, if you are willing to add, so that you can add here in this way, and dz directly you can write. And z, limit of z will be 0 to this one, y plus z is equals to 4. So z is equals to, it will be 4 minus y. So by integrating that by natural, you will get 4 minus y. So either triple integration or double integration that can be used. So how we solve this? We use here the polar coordinate, because in the circular region it is very quite easy to get. So the required transformation will be x is equals to r cos theta, y is equals to r sin theta, and the Jacobian j will be r that you know. So the required integration v will be what? So it is angular moment 0 to 2 pi, and r will be 0 to 2, and z will be 4 minus y, so it is 4 minus r sin theta. This r is the Jacobian, and dr d theta that we get. So after solution, what we get the answer, that is 16 pi. So here you can also do in such a way. If you are integrating with respect to r, so it will be 4r minus r squared. So integration of 4r minus r square sin theta dr, and r is equals to 0 to 2 is the limit. So what we get, r square by 2. So it is going to be 2r square minus, this will be r cube by 3 sin theta, and the limit will be 0 to 2 that we have to put. So 0 is no issue, lower limit, all the terms is going to be 0. Once you put, it is 2. So it will be 4 into 2, 8, minus, it will be 8 by 3 sin theta. So now you are integrating with respect to what? Theta. So it will be integration of 8 minus 8 by 3 sin theta from 0 to 2 pi. It is d theta. So what we get, it is going to be 8 theta minus 8 by 3, and sine will be minus minus plus cos theta, and the limit will be 0 to 2 pi. So no issue with the 0 to 2 pi, it is going to be 0. So only 8 into 2 pi that we get, 8 into 2 pi. So your answer is 16 pi is the right answer. So in this way you can match your answer. So I hope so this solution will be helpful for your future purpose also. So thank you for watching this solution. So you can like this video, share this video with your friends, colleagues, those who have given the examination, and you can subscribe my channel if you have not subscribed yet, and you can comment on the comment box about this video. So once again, thank you for watching this video.